Hello and welcome to our webinar on automation potential in the biomedical industry. Thank you so much for being here. I'm Nick Erickson, your host for this webinar. Today I'm joined by Richard Spiegel, an automation specialist here at Instron. Richard has been with Instron for 7 years, all in the automation and custom engineering group, known at Instron as ESG. He was a senior automation engineer where he designed and integrated automated testing systems. Then he managed the custom manufacturing group. And finally, last year, he jumped over to the product side to work closer with customers, developing and prescribing automation solutions to fit application requirements. We're also joined by Landon Goldfarb, who is our biomedical market manager. Landon spent a number of years as an applications engineer before narrowing his focus and expertise on the biomedical market. He is our go-to person for biomedical testing and has a hand in new product development for novel applications and helps customers improve their mechanical testing processes. As the title of this webinar suggests, these two are here to talk about automation, some of the trends in the biomedical industry, and the range of automation solutions that address some of the new challenges associated with increasing demands for testing labs in this space. We do expect the presentation should take around 30 minutes, which should leave us around 15 minutes for questions. If you do have questions, please use the Q&A icon to submit these anytime throughout the presentation. We will plan to address these at the end. I also want to mention that we are recording this webinar and that all of you will receive an email afterwards with a link to the video, and it will also be available on our website, instron.com. So with all that said, I'll turn things over to Richard to get us started.
Hi, thanks, Nick. There we go. All right, I'm going to start with more high level, just trends in automation.
Oh, you'll just want to switch your slides.
In there, thank you.
Perfect.
All right, so automation and bio. So there's been a lot of global trends towards adding robotics into a lot of different industries, you know, everything from manufacturing to testing. There's specifically been a lot of growth recently in lab automation. So automating the quality control, R&D testing that's needed to be done. Kind of robots have worked their way out of traditional manufacturing environments and kind of into the next stops along the way in the process for product development. So global market investments in lab automation was $5.2 billion in 2020 and forecasted to grow up to almost $9 billion in 2028. So that's a CAGR of just over 8%. And what's driving this huge growth? You know, 8% a year is a lot. Stricter regulations requiring a higher demand for higher accuracy and more test results. Specifically in bio, I'm sure everyone's noticed, there's been an increase in spending on healthcare, leading to more R&D into technology for improving the processes. And companies are needing to increase the amount of testing they're doing, ideally without adding more personnel. So the product intricacies that are being developed now are having higher driving price pressures to drive prices down. And to do that, you got to lower the amount of money needed for testing. Safety and ergonomics. The safety requirements are constantly growing. I know when I started in industry about 10 years ago, we used to be able to go and get a Band-Aid if we had a scratch or something. And that was that. You just needed to go get a Band-Aid. If I were to get a Band-Aid today, that's now an OSHA recordable. It's kind of the same injury, but the requirements are changing. So with that, trying to automate increases the safety by removing the risk from the operator. So dangerous chemicals or specimen testing procedures, reducing and minimizing physical strain. Some lab equipment is not really designed around the ergonomics of the operator. It can be difficult to load in and unload, as well as just the repetition of the amount of testing needing to be done can lead to strain injuries. As well as there's just a general displeasure by some operators in some tests. Some are cumbersome or not fun to do, to sit in front of the test gram. So with that, why should companies be looking to automate? So the manual processes in the test lab are very time consuming. You get hours spent by operators in front of these test machines, as well as humans aren't necessarily doing it the most efficient way. They kind of learn how to do it one way, and it can be difficult to change. Whereas robots, we're programming them, or they're being programmed in the highest efficient way to do it, minimizing movements. High volume samples can be processed easily without breaks or added supervision. You hit start and walk away. The training time is also significantly reduced. In general, it's much easier to train an operator on how to run automated equipment than it is how to run that same equipment manually. The learning curve is just lower. So with that, the cost effectiveness of automation really increases the productivity in the lab with a single capital investment without adding further lab personnel. And with that, it can free up the lab personnel you do have for other more mindful tasks, things that require a human to do. They are also, operators or lab technicians are also able to multitask. While one system is running, they can set up another automation system and having multiple frames running simultaneously. In addition to that, the robots and automation, they never get tired, sick, or go on vacation. They're always running over and over again. Turn the lights out in the lab, and the automation system is still going to keep running. Increase quality. So an automation system is going to run the same procedures with the same parameters and do it the same way every time. The repeatability of the robots and cobots and linear actuators is just higher than any human can maintain. The process steps are always the same. So the robot's going to do the same thing every time, and it's going to keep doing it that way until you tell it to stop or until it gets programmed to do it another way. This produces very reliable and consistent results. So now that I've talked about the generals behind trends in automation and why you should automate, I'm going to hand things over to Landon, who's going to work on, or who's going to show some of our automation systems.
Hi, everybody. So I'm going to talk a little bit more about what automation could actually look like in your lab. I think Richard did a really good job of talking about why are companies moving towards automation? What are the trends pushing companies in that direction? What are the benefits they can get out of it? But I think, it's really important to see, well, it's hard to sometimes visualize what does automation actually look like in my lab? How will it work with my applications, with my specimens? So today I have two systems here that really showcase some of the smaller scale applications of automation. And I wanted to show these two, but I think it's important to note that the automation offering that we have is not solely limited to these two style of systems. We really have an entire platform of automation that can scale in terms of size, throughput, with whatever part of the product development process you are working on. So smaller systems like these could have more of a home inside of a design verification lab or a center of excellence for testing. And as you move into more production style quality control environments, you can have larger scale systems that are designed to accommodate much larger capacities of specimens and much larger amounts of throughput for your testing. And I think that really is one of the biggest misconceptions that a lot of people have about automation. I think a lot of times people assume, well, it's having a big robot tied to a production line, and it's a really large capital investment. And I don't know how I would actually use that if it was to be inside my small design verification lab. It's too big, it's too cumbersome. It really can't handle the nuance of the testing I'm trying to do. And I think really, trying to showcase that there are other options for companies that want to add automation. They're looking for that increased level of productivity. not only inside the production environment. So that's really what I want to talk about today with these two systems. And kind of going back to the really large capital investment piece of it. One thing that's really important to know is these two systems behind me, which I'll get to, they really are both retrofittable to existing pieces of testing equipment. So it's not always that you need to fully invest in a totally new system. You always have the opportunity to add automation to existing systems. And I think that's a really crucial piece of it. And even beyond just adding, some fully automated setup like this, there are always ways to add even smaller levels of automation or simplification into your testing processes, whether that be through automating just the specimen measurement piece of it, automating how you collect the data and export the data. There's always ways that we can help partner with you to ensure that you are getting the most productivity and the most out of your system that you possibly can. So let's now talk about the two systems that are behind me. I'm sure you've seen the flurry of activity going on behind me. So we'll start talking about the XY Stage system. So this is also known to Instron as an AT2. It kind of goes with the family of automation systems. 2 meaning there's 2 degrees of freedom. We also have systems that are 3 degrees of freedom and 6 degrees of freedom, depending on the amount of throughput that you're trying to achieve. So an XY Stage system is basically an automated stage that we can control to test arrays of specimens in a single test run. Here we're actually testing the residual seal force of a sample of vials. And this is, it's actually a relatively slow test. And when you think about the time required to take the specimen out, reseed it, and get the next test going, we've done some studies and shown you can save 40–50% of your time moving away from a manual solution and more towards an AT2 style solution. In terms of what use cases there are for an XY Stage, obviously testing large arrays of simple compression style testing is one of them. But another one that crops up a lot, especially within bio, being such a component heavy industry, is actually testing multiple parts of a product in a single test run. I've actually had instances where a customer was testing an ablation probe, and they were actually testing with a bath on an XY Stage and testing multiple points along a piece of tissue. And they wanted to understand at different points what is the force required to use the probe on the specimen. So that's another really helpful part of the XY Stage is you can use it to test multiple locations of a component very repeatably, time and time again. And that's a really big part of it. So we can quickly look at, and I think one of the other really important things about using an XY Stage, and probably the question customers have all the time is, how do I, fixturing, how does that typically work? So these stages have a mounting pattern attached to the top of it. And we, as a company, can provide all of the racking for your specific product. But if you're going to be testing a lot of different sizes of specimens, there's nothing stopping you from creating your own racking and swapping it out in between tests. So in terms of, actually, how do we control an XY Stage, especially if we're doing one of those more complicated movements where we need to test random locations on a component repeatably over and over and over again. So I'm actually going to stop a test so we can look at the software. So you can see on our live displays, you can see the position of the XY Stage in the X and Y axis. If you wanted to move the stage, all of that is done directly through the software. You have control to move it in any direction, move it to a 0 point. There's also an optional joystick to improve just the tactile feedback of how you can move it. And in terms of actually setting up a test, I mean, what that really looks like. So when you're going into the method, you're going to test control. How am I going to set up my test? The XY Stage is immediately built into the software. And you can set up different test sequences. So you can say, hey, I'm doing a grid and I know that my delta between each position is this amount. This is the number of rows. This is the number of columns. This is where I want to start. And that is all that is essentially required to create a test. Past that, you simply hit start and the software knows to run through each specimen in that grid in the order that you have specified. In the case where, let's say you were trying to test a component, you do have the ability to add different types of sequences. So you can do a diamond, you can do custom or a grid. So if you do custom, you choose individual points that you want to run your test on. And you actually have the ability to import those points in an Excel file and immediately populate the profile of the XY stage. And if you have a CAD model of the component you're testing, it's much easier to get those points in CAD, put the actual points into Excel and then import it here, than manually go through the process of moving the stage to each correct point. So there's a lot of flexibility with how you use the XY stage, how you set it up and run a test. So you can really get from having a component to starting to run a test in 5-10 minutes once you get used to the software and are very comfortable running with it. So that is, I think, a pretty good overview of what the XY stage is. We're going to move over to the Cobot setup, which I'm sure is the one that's a little bit more eye-catching. I'm sure a lot of people have seen this type of product, a Cobot, in other circumstances. It's in a lot of manufacturing processes. So basically, what is a Cobot and what is the difference between a Cobot and a robot, industrial robot? I mean, there's a lot of nomenclature out there, but what really is a Cobot? So it stands for collaborative robot. And really the main difference is, I mean, you can see, you can have it in an unguarded state when working in tandem with your system. With most and pretty much all industrial robots, safety requirements require guarding around the entire system, which if you are in a small lab, that can be a real detriment because you really might not have the space to have a fully enclosed guarded system in your lab. And the reason that you can have it unguarded is because there's built-in force sensors in every axis of the Cobot. So if at any point during the test, you were to bump into the Cobot, it'll automatically recognize that force and stop the test. And one important note is that the integration of the Cobot with the frame, they are communicating and the safety circuits are also integrated. So if you did knock into the Cobot and it were to stop the Cobot, that same message would go to the frame to stop the frame as well. And the same would be vice versa. If you were to hit the e-stop on the frame, that would also stop the Cobot from moving where it was. The other big difference with a collaborative robot is really the ease of use in terms of programming it. When you think about more traditional industrial robots, a lot of the coding is really computer programming. You have to tell it exactly where to go via code. The Cobots specifically are really designed to be user-friendly in terms of setting it up. You can even take the Cobot and show it where you want it to go, and then teach it that way to teach it one profile or another. Obviously, if you're doing some sort of array palletizing routine, you can even shorten the amount of steps it takes to program it by just telling it how far apart each specimen is. And that really is the biggest upside of the Cobot, is that the flexibility around it. Especially in the case of a lab that may be testing a lot of different specimen types, they could very easily adjust the profile that the Cobot is following to work to pick up a specimen, place it into your system and run your test. So you get that immediate benefit of reducing the impact of operators pretty much once you start working with the Cobot. So let's actually start running the Cobot, see it in action. So if you look at the plate that it's sitting on, so this is really the most compact design that we could put together to have a Cobot and a frame work in tandem. And this is really coming from customers who are really trying to fit automation into their existing lab space, onto their existing lab benches, where there can be real limitations in terms of space. So in this setup, you are only adding an additional 8 inches of width to the system, and that's it. Aside from that, it is the exact same footprint as a normal single column system. One thing also, so you'll see the racking, obviously, this is a demo system. So this is more of an example of what the racking could look like to really achieve the gains in productivity that most people would want to. The racking would accommodate many more specimens. You could have multiple tiers of racking. So you could have 30, 40, 50 specimens. And that's also not to say that you are beholden to this setup with this plate on the system. If the one thing we always have to talk about with customers is there's always a trade-off between the amount of footprint that your system has and the capacity of the system. So if it was crucial that you had to test 100, 200 specimens, we could accommodate that. The Cobot has the reach to handle additional racks. It will just require more room footprint-wise in your lab. So that's always something that we will want to talk to you about, understand really what are the requirements that are pushing you towards automation, because these systems really can accommodate a very wide range of applications and lab requirements. So this test, we have a syringe that is being placed into the fixture, and we're doing a pull and push of the plunger of the syringe. So similar to a break loose glide force, but we're also doing the aspiration step of it as opposed to just depressing the plunger of the syringe. So a little bit different. And in terms of interacting with the Cobot, all of that is actually done through Blue Hill. So Blue Hill is always in communication with the Cobot. It is telling it when you hit start in the software, it is telling the Cobot to start the program. You choose a program within Blue Hill, and it automatically starts. And you actually have the ability to choose multiple programs to be included within one method. And basically, the use case of that is, you can actually see that there is a failed test bin on the stage. So if there was an instance where you wanted to put in specific pass-fail criteria to your test, you could tell the Cobot, if the conditions are X, put the Cobot back into the racking system. And if the conditions are Y, put the specimen into this failed specimen bin. So you can understand and find the specimens that have failed and do a more in-depth failure analysis to understand why that could have occurred. And in terms of the usability of the system, it really is very much integrated with the frame. All of the controls are still through the frame controls. Start, stop, all of that is done the same way you would normally use a system today. And then one thing that, if you actually look at the software, you can notice we always have what's called the active zone. So you can see in text what the system is doing at all times. And that's really useful when a Cobot is running especially. So what is occurring with the Cobot, even if things do happen. In this case, the specimen did not make it into the fixture. But like I said, the active zone can always follow what the Cobot is doing and make it very clear to an operator how the test is being run. In any case, this will probably be a good reason to see what would happen if a specimen failed. So this way you can still acknowledge that a specimen was not tested properly, and it'll put it into the failed bin. So, there's a silver lining to it anyway. So I think that, really does show a good part of the usability of the Cobot, what it typically is used for. And, I think one point something that I've started noticing a lot in dealing with customers and talking to people is that more and more there are positions that exist within companies that are people solely focused on trying to optimize all of their lab testing procedures. How can I get the most efficiency, the most productivity out of all of my lab processes? And I think that really is showing kind of the commitment that a lot of companies have to introducing automation and to trying to get as much productivity and efficiency out of their testing systems as possible. And one thing that I think is really important too is, obviously automation, especially within bio, being such a fragmented market, there's so many different types of products, there's so many varied devices and specimens. There is no one size fits all solution, even in automation. So we do have a dedicated automation engineering team who is, solely focused on working with your company to understand what are your specific requirements for this device, for this component, how can we automate it, and how can we really take as much of the operator interaction and opportunities for error out of your testing process as possible. So that really is, a big part of, being Instron being a partner in the move towards automation. It's not just having solutions that can work for automation. It's really working with your design and engineering teams to find the solution that works best with your existing processes and getting the best combined solution that would benefit your lab. So that, I think, really does cover a lot of what I wanted to show you in terms of the two devices here. Obviously, on our website, we have a lot more information about what other types of automation exist within our platform. Specifically, if you're interested in more about the larger scale production type automation, we'd be happy to, all of that is on the website. So I think at this point, we'll open it up to questions and answers, and hopefully clarify anything that may not have been clear. And if there is anything very specific, we will obviously be happy to talk to you offline, or set up a meeting to talk about, how we can bring automation into your space.
Great, thanks, Landon. One question here. You mentioned this for the XY, but can customers design their own fixturing and racking for the Cobot as well?
Yeah, no, absolutely. So the Cobot, similarly to the XY, has mounting patterns on the platform. So you are obviously free to produce your own racking, fixturing, that'll work with the Cobot. So there's no limitations as to what you can and can't put on the stage. But like I said, if you were looking for a turnkey solution, we have the engineering means to provide a full system that's specifically tailored to your product.
Another question here. Can we add automated measurement or other third-party devices to these automated systems?
Yeah, so with the larger AT3, AT6 platforms, there's more opportunity to add third-party devices, whether that be measurement devices, hardness testers. On these two systems here, as of right now, they are limited to kind of the scope of just the automated systems and the frames. But there is opportunities in other parts of our automation portfolio to add other third-party devices.
Another question. Guarding for the Cobot, is that ever required? So I can answer that. So the guarding and the risks are application dependent. So if it's the risk of moving around your device, say a razor blade, the risk of moving that around in the Cobot is different than moving around a syringe with no blade attached. So it's application dependent, and we are able to integrate shields or enclosures around either of those devices and link the safety circuitry as well. Okay. It is 1:30 now.
Is that all the questions we've got? Looks like it might be. Okay.
One question just popped up. How does the communication between the test frame and Cobot work? So that is Ethernet based. So we tie in to the UR software using Ethernet control and are able to send commands back and forth using the API for the Cobot and the API for Blue Hill.
Okay. Well, it looks like we've got all the questions addressed, but if anything does kind of come in as I'm wrapping up here, I'll make sure to get those questions over to Landon and Richard to address after the fact. And just a reminder that we did record this or are recording it. So I'll email each of you a copy of today's recording so you can reference it again or share it with colleagues, whatever you'd like to do. So with that said, I just want to say thanks to Landon and Richard for presenting today, and Jeff in the background as our videographer for Landon. And thanks to all of you for attending. Really appreciate you joining us, and we hope to see you again at one of our future webinars. And then just enjoy the rest of your day.